Thanks so much. So I'm delighted to be here and talk about the 6G-XCEL project. So 6G Transcontinental Edge Learning. I'm Professor Dan Kilper with the Connect Center at Trinity College Dublin, where I'm tech manager, and we're coordinating the project. So this is an EU-US cooperative project for on AI for 6G. So we're bringing together a large ecosystem of partners from the EU and the US. It's a 3 million research and innovation project for 36 months. We've got 10 partners in the EU and 10 partners in the US. And but importantly, we're really bringing together 9 major initiatives across both of these regions. So for our European partners, we have, for example, the Slices testbed by Sorbonne University and IMEC, and of course there's the IMEC City Lab as well. And then at Patras.
Dona Susana Condisso, se ela já tiver chegado.
Please mute yourselves, or you can also try to do that. Yeah, thank you. Please go ahead.
Sorry, University of Patras and the PNET testbed there, and working with SME Daikinez and Juniper. We have HHI and Deutsche Telekom and the I14Y lab. And of course, in Ireland, we have the Open Ireland testbed, and we're working closely with IBM. And we have University of Aalborg as another partner. And then in the US, we're cooperating with some large initiatives there. So there's the Cosmos Power Platform funded by the NSF and the NSF Center for Smart Streetscapes. And this involves Columbia University and Rutgers University. We're also working with IBM and Nokia Bell Labs there. And then the Athena AI Institute is a large NSF AI institute led by Duke University. And the Commonwealth Cyber Initiative is run by Virginia Tech. And then we have other industry partners, AMD, Apple, and Juniper. So we were very interested in trying to solve the problem, the fragmented kind of network AI environment that we have for implementing AI end to end, right? So if you're doing something end to end, you're working across both the radio and optical physical layers, and that means involving the RAN and transport networks and how you implement AI in each of those, as well as the multi-domain problem of implementing AI across different network operators. And we refer to this as kind of an east-west sense of implementing end-to-end AI. But we also recognize that the AI needs to work across both the physical layer devices, the actual communication systems, through the networks to the data centers and the software systems and services. And we refer to this as kind of a north-south implementation that also works across the different layers of the network. So our vision in 6G-XCEL is to do research on edge network use cases that employ decentralized multi-party AI controls running over edge compute accelerators to coordinate control across radio and optical networks. And for this, we'll develop a reference framework for AI and 6G that will pave the way towards global validation, adoption, and standardization of AI approaches. This is the decentralized multi-party, multi-network AI framework, which we refer to as the DEMI framework. So this will enable federation of AI-based network controls across network domains and physical layers while promoting security and sustainable solutions. And we want to develop reference use cases, data acquisition generation methods, data and model repositories, and curated training and evaluation data. So technologies and functionalities for its use as a benchmarking platform will be developed for future AI ML solutions for 6G networks. Now, as I mentioned, very importantly, we're trying to bring together this large ecosystem of researchers from the EU and US to implement elements of the DEMI framework in their test beds and labs. So this framework would be a unifying activity across the EU and US to implement and look at its performance in these different environments and study its interactions and interfaces. So integrating it into the research programs that are going on in these various test beds and validating the framework across the platforms. So the objectives of the project are to investigate and design the DEMI framework. And we want to look at specifically the timescales associated with this framework in terms of real-time, near real-time, and non-real-time control loops. What can you achieve when you're in this distributed multi-party, multi-network environment? We want to develop efficient and scalable methods for handling large scale time series data. We also want to investigate methods to address the security and privacy of the DEMI framework, and then also its energy efficiency. And then we have an objective to create a flexible framework that can be used across and interact with different AI orchestration platforms. So this is not about AI orchestration. This is a framework that would be utilized by various orchestration platforms. And then lastly, of course, we want to establish a community of excellence in research on networks and AI spanning the EU and US to provide a foundation for its use in 6G. So this is how we view the AI framework, the DEMI framework. So it's really what we call an AI controller that would be embedded in different RIC platforms on the radio side, as well as network OS and transport SDN controllers on the transport side of things. And the framework involves these controllers and their interactions, how they communicate and work together to implement AI algorithms end to end. And importantly, that these controllers need to also work with AI service management and orchestration platforms. So this is how we view the controller. It's basically a set of model and accelerator repositories, as well as network data and abstracted data repositories, curation and DSP tools, as well as, importantly, in the middle there, you can see there's north-south communications and east-west communications that helps to enable those different modes of integrating AI across the different domains and networks. And then we have testing and validation functionalities and policy controls and supervision. And so then this controller or set of tools needs to not only interoperate amongst themselves, but also with, as I said, the various AI service management and orchestration platforms, as well as with user AI tools, which would be similar types of repositories, as well as third-party AI or other X apps and R apps. Okay, so that's the basic framework. And then to implement it, so Juniper has an advanced production kind of ORAN environment and that we'll use for implementing in two different ways. So one is that we can code these AI controllers up as X apps and R apps and embed them within that framework, but also we're going to look at advantages from building it into the framework. And then importantly, for the various test beds that we're working with, many of them have their own open source RICs and transport SDN controllers. So we'll implement these AI controllers in the various test beds in these open source environments as well, and have a set of open source tools that people can use for that purpose. So this is the work package organization. So we'll look at application and orchestration requirements, and then that'll feed into the design and implementation of the various AI controller elements and the various platforms. And then we'll, in work package 4, look at the performance and security analysis of the overall DEMI framework. And then importantly, we'll be
Dan, you have 1 minute left. Thank you.
Thanks. We'll be integrating these into the different test beds and environments that I mentioned. So Open Ireland, Cosmos, PNet, CCI, Virginia Tech, CityLab, and Slices. So they'll be available to the broader community as well. And we want to very much engage across the entire community here to start using these tools and to help us to develop the tools. So the idea is that we develop it all together and create a framework that really allows us to benchmark and work with AI and 6G in a meaningful way. So that's the word. That's cooperate. I'm very happy to talk with others about the project and hope that we can engage with other projects across the SNS program. Thanks.